Hey guys, so it's a bus day. I figured I would make you a video on what we were going to go through today. Also, this will help the people that are gone on the ski trip. So today, what we would have been looking at is carboxylic acids, esters, and the esterification reaction. So the first thing we're going to look here at is the carboxylic acids. So carboxylic acids are a family of organic compounds that contain a carboxyl group. So a carboxyl group contains both a carbonyl, which we haven't quite talked about, and a hydroxyl functional group. So what it looks like is on the end of a molecule, you will have a carbon that is double bonded to an oxygen as well as bonded to a hydrogen. So because the carboxyl involves 3 of the 4 carbon bonds, the carboxyl is always going to be attached at the end of the carbon chain. Here are some characteristics of carboxylic acids. They occur naturally in some types of fruits, so citrus fruits, crab apples, rhubarbs, as well as other sour and tangy fruits. We'll look at a few other examples here in a second. They also have distinctive odors because of that carboxyl group. Additionally, because of the carboxyl group that double bonded to an oxygen and an OH, that will make your hydrocarbon that it is attached to become polar, so that would increase the boiling points as well as add dipole-dipole forces, which would make it soluble in water. They would also form hydrogen bonds with other carboxylic acids and with the water molecule, making them stick together stronger and harder to break apart. They also exhibit the same solubility as regular alcohols. And lastly, because of the carboxyl group, the end of the molecule is arranged in a planar arrangement, so it would just be shown in one dimension. So carboxylic acids are responsible for some interesting properties in different compounds. So for example, formic acid, that's responsible for some of the sting in some types of ants. Acetic acid, that's what's in vinegar, and that's that sour component of vinegar. It also is responsible for if you leave wine out for an extended period of time, it kind of gets a bad taste, and that's because the ethanol decomposes into acetic acid. The last one is butanoic acid, which is the reason for some bad smelling body odors. So just some kind of interesting facts about carboxylic acids there and their uses in daily life. So naming carboxylic acids, what we are doing here is whatever the corresponding alkane is, you remove the E from the name, add the ending of oic, followed by the word acid. So for example, methanoic acid, which is commonly referred to as formic acid, comes from methane, and then we take off the E in methane, add the oic, and acid at the end. And so you can see this is a single carbon double bonded to an oxygen and bonded to another hydroxide, and that's that carboxyl group. Ethanoic acid kind of works the same way. So I have a 2-chain carbon chain. The one of the end carbons is double bonded to an oxygen and to a hydroxide, so that's the carboxyl group. So I would change the name of ethane into ethanoic acid. And again, that's just what is kind of gives vinegar its taste. Here are some further examples when you have multiple carboxyl groups attached. We don't really have to look at or know the common names or names for these examples. Just know that you can form multiple carboxyl bonds, and so you need to also recognize that multiple hydrogen bonding is possible with a carboxylic acid, and so the more carboxyl groups you add, this will increase the melting and boiling point because of the additional hydrogen bonding and polarity that that molecule would accumulate as you add these COOH groups. Okay, so we're going to look at the naming, some steps for naming carboxylic acids here. So here's the example we're going to look at. So here's the example we're looking at. So the first step you would need to do is select and name the longest chain of carbon atoms. So if I was to find and number my carbons here, I would say, you know, there's a carbon here, carbon here, carbon here, and a carbon here. So this would be my longest carbon chain. So technically right now this is a 1, 2, 3, 4, 5. So this is a pentane, is the longest carbon chain. Then my second step to name this from the alkane to add the carboxyl on is I get rid of this E ending, and so this becomes pentanoic acid. Then what I would do is start numbering this from the carboxyl group, and then to the left in this case, so 1, 2, 3, 4, 5. And then any side chains, we would do the same as we did before and put their names in front of this. So this methyl group would be a 2-methyl pentanoic acid. Okay, so let's look at a few examples here. So it says write the IUPAC name for the full structural formula. So again, I need to kind of go find my carbon. So there's a carbon here, a carbon here, and a carbon here. And I would number this 1, 2, 3. So 3 is monkeys eat peeled. So this is right now, if I was just looking at it as if it was an alkane, it would be a propane. If you notice on this molecule, there are no side chains. So I could just name this propane. I drop the E, and so this becomes propanoic acid. Just a very basic name. The next example says, what is the IUPAC name for this carboxylic acid, which has an unpleasant rancid odor? So again, my first thing to do is go find the longest parent chain of carbons that include the carboxyl group. So a carbon here, 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 and here. You know, again, that parent chain doesn't have to be straight. So this is a 1, 2, 3, 4. So it's a butane if I was ignoring the carboxyl group. And because there's this carboxyl group on it, I drop the E, so this would become butanoic acid. Okay, so if you have a second, please just try and pause the video at this place and try and answer these two questions on your own. Drawing the structural formulas, and then as well, given the formula, draw the name. So take a second and try that if you can, please. Not the highlighter. Okay, so octanoic acid, so this would have 8 carbon chains, so 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. And then on this last carbon, I have a carbon which is double bonded to an oxygen and to a hydroxyl group. So that should be, I guess it says structural formula here. I drew the line structural formula for octanoic acid. Pentane diiotic acid. Now this right here is just slightly different than what we have seen before, but hopefully you were still able to take a look and kind of maybe figure it out. So that prefix di here is telling me that there are 2 carboxyl groups attached, carboxyl groups attached to the pentane chain. So carbon, 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 carbon. So a 5 carbon chain, and carboxyl groups can only occur on the end of a molecule. So I would have this double bonded to an oxygen and a hydrogen here, as well as on the other side bonded to an oxygen and to a hydrogen. And everything else I would just add on my hydrogens. For the second example you were supposed to try, all you need to do is provide the IUPAC name. So this one here just has a single carbon bonded to a carboxyl group, so technically it's methane. I would get rid of the E at the end, and this becomes methanoic acid. The last example you were supposed to try is a 1, 2, 3, 4, 5 carbon chain attached to a carboxyl group at the end. So this would become pentanoic acid. Now these can have, you know, like halogen side chains, or they could have a methane or a methyl group alkyl group attached as well. So if this was my molecule, now if I added this, this would become a 1, 2, 3, 4, 5. If I'm numbering my carbon chain, I start from the carboxyl group. So this would become a 3-chloro 2-methyl pentanoic acid, if there is additional side chains on there. Okay, here's a test-like question. I think we'll go through this together in class. Okay, so carboxylic acids can undergo a variety of reactions. The one that we're really concerned with here is a type of condensation reaction, and so condensation reaction means that we are removing some sort of an organic compound, usually water, right? Like condensation usually talks about water. And so what's happening in these condensation reactions of carboxylic acids is that the carboxylic acid adds to, some other group. Now, the particular type of reaction we're looking at is the carboxylic acid is going to react with an alcohol. And so if you remember, alcohols have that hydroxide group attached to them. And in this reaction, when the carboxylic acid and the alcohol combine together, we get this new molecule that we're going to look at here in a little bit more detail called an ester, and the part of the carboxylic acid and the alcohol react to give me a water. This type of reaction is called a esterification reaction, where I have an ester being produced from the reaction of a carboxylic acid with an alcohol. And so first of all, before we look at further esterification reactions, let's take a look at what an ester actually is. So an ester is a functional group similar to that of an acid, except the hydrogen atom of the carboxyl group has been replaced by a hydrocarbon branch. So what that looks like is, this is actually occurring in the middle of a molecule. So I have a carbon double bonded to an oxygen, which is single bonded to an oxygen, and then this connects to a hydrocarbon chain, as well as this side of the carbon molecule attaches to another hydrocarbon chain. And so we have this general formula for an ester, where I say R and R prime, where those are side chains. So an ester is a little bit different than the other groups that we've looked at. We see this kind of occurring in the middle of our molecule, and we're going to look at how to name that here in a second. But first, I just want to look at a list here of different esters. So these esters are compounds that are responsible for different types of odors, whether they are artificially or naturally occurring esters. They're responsible for the odors in apples, apricots, bananas, cherries, oranges, pineapples, which is kind of an interesting real-world application of these esters that we can see. So I'm going to continue here in a second video. So continue over to the part 2 video.